Hello and welcome to Mellow Labs. On today's episode, I'd like to talk about my stupidity. Pretty much like every other episode, I know, but besides the point, recently I made a environmental/presence sensor for my kitchen, and I'm currently working on the same thing for my bathroom, and I wasn't gonna make a video about it because I was just gonna pretty much carbon copy it and put it in a different enclosure to fit my bathroom. But it was whilst planning that out, I realized that I'm about to make a mistake that I made like 4 different times already. I should probably learn from my mistakes at some point, and it's to do with the temperature sensor. Normally I use something like a BME280 or a BME680 or whatever one of those cheap temperature sensors I have at hand, and normally they work just fine, except that a bathroom is a high humidity environment, so after like a shower or two, the sensor dies. And that's what happened to me the first time, and I was like, I wonder why. Let's just replace the sensor and try again. And then it died. And then I was like, must be the humidity. What if I put some sponge around the sensor to prevent humidity getting into it? And surprise, surprise, it died. And then I thought, okay, I will make fancy 3D printed geometry that will prevent the moist air from getting to the sensor, which also prevented any good readings coming out of that sensor. And eventually I just kind of gave up. And now I finally decided to actually do some research, and I found out that the sensor I needed is this one. It's called the SHT40. Well, specifically it's called the SHT40, but I like to call it SHT40 for short. And I'll tell you all you need to know about it right after this message from today's sponsor. JLCPCB has exactly what you're looking for, whether you're a beginner trying to make your very first PCB or a professional looking for more advanced options. JLCPCB has you covered. Need a simple board just to bring an idea to life? They can do that. Need something a little more serious, like a transparent flexible PCB with aluminum backing and V-ring pad for space saving and an ENIG finish? Well, JLCPCB can handle that too. Getting started is super easy. Just click and drag your Gerber files into jlcpcb.com, select what options you'd like to use, and you get an instant quote. Now I know all of that might sound really expensive, but it really isn't. Because of JLCPCB's large scale, they can bring the savings down to you, and they pretty much always have some kind of deals or coupons going on. Like right now, you can get $30 off of a 6-layer PCB, which brings the starting price down to just $2. And if you're a new user and you click the link in my description, you can get $123 in new user coupons, which makes your first few routing mistakes a lot less painful. JLCPCB does everything in-house with strict quality control at every step, and you can see that progress in your dashboard as you're waiting for your order. And for more complex boards, they'll even x-ray them and send you the images so you can see that everything is placed correctly as it should be. Check out the links in my description, and when you think PCB, think JLCPCB. Easy, affordable, and reliable. So what exactly makes this sensor better than these sensors? Well, I wouldn't actually say it's any better. When it comes to accuracy, they're pretty much in the same ballpark, but this one has a built-in integrated heater onto the chip itself. So when things get too hot and steamy in the bathroom and moisture starts settling down on the sensor itself, you can tell it to turn the heater on, which will evaporate the moisture, preventing it from like going into the sensor itself, causing havoc the way water normally does with electronics, and breaking it. And speaking of breaking it, I bought 2 of these on AliExpress for like £2.50. I'm sure you can get a better deal somewhere else. And I connected it to an ESP32 to actually, see how it works and all that. The problem is I connected it to 5 volts and I didn't read the data sheet. They do not like 5 volts. Connect it to 3.3. I learned the hard way. So I got 2 of these so that I can play around and experiment with one, like dunking it in water and seeing things like that. But now I only have 1, which I actually need for the project. So I still want to do some experiments, but I'm not going to get as creative as I would have otherwise. So first of all, I think I want to have a look at it under the microscope. You can buy the sensor in like different packages. I went for the probe, but you can also get it in like the regular breakout board kind. And to get it out of this probe, you kind of just tug on it. They've crimped it, but they didn't really do a great job, so they don't hold on that great. But yeah, the inside here, there's just a little PCB with 4 wires and the sensor itself and like a capacitor and 2 resistors. And that is kind of it. There is a closer look at it right there, and if I put in a BME280 just for comparison, it's actually quite a bit smaller. Right, I want to have a look at this under a thermal camera to actually see the heater come on. Actually, before I continue, I want to talk about some basics about the sensor, like the fact that there are 3 different SKUs of the same sensor. There's the SHT40, SHT41 and SHT45, and the only difference between them is the fact that they get a little more accurate with each number. I suspect it's exactly the same chip, it just gets assigned a different number depending how well it performs in the factory calibration tests. The heater itself has 3 different modes. There's high, medium and low, so you can just adjust the temperature depending on how humid your environment is, and you can pulse it on for either 0.1 seconds or 1 second. The maximum is 1 second. It won't let you go for longer than that. You have to like tell it to turn on for 1 second and then it will turn off, and then you have to tell it to turn on. It's a little annoying, but it makes sense because you don't want the chip to like desolder itself from the board and just fall off. Voltage range is from 1.8 to 3.3, not 5 volts. I learned the hard way, don't do what I did. Obviously it uses I2C, it has a temperature range of -40 to +125. I don't think we'll be taking showers that hot, so I think we're in the clear. And a humidity range of 0 to 100. So I suspect you can just like dunk it in water and it'd be okay, but I'm not willing to find out with the only working unit I have. Oh, I'm sorry. Hello? Oh, it's the YouTube algorithm. Apparently 80% of you are not subscribed to my channel. How dare you? Please hit the button. Oh, and also hit the like button. Apparently that helps as well. Oh, really? Oh. Really? Okay. Don't worry about that. Let's just continue with the video. I've got the thermal camera set up. This is the P3 from Thermal Master. I'm not sponsored, but it's a good camera because you can focus on tiny things and big things. I'll leave a link down below, blah, 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 blah. I've got 3 points set up. So I've got point 1 being the actual sensor itself and 2 and 3 for like ambient temperature sensing. And I've got a script running that will turn the heater on for 10 seconds and then turn it off for 10 seconds. Obviously not on for a whole 10 seconds because you have to do it in 1 second pulses. So it pulses it for 10 seconds. It doesn't matter. So as you can see, the surface temperature of that chip goes like up to 100 degrees, which is kind of what we expect because, you know, we want to vaporize water off of the surface. But the internal temperature apparently goes, well, it probably goes above 130, but because the limit of the sensor is 125, it's probably just, you know, limiting itself. So yeah, you can actually just see it just pulsing on. It's very mesmerizing to watch. Now, obviously, you're not getting very accurate temperature readings and humidity readings whilst the heater is on. It's not really a problem because if you're using this with like ESPHome, like I am, it actually just stops reading the temperature during the parts when the heater is on, and it also recommends you do the same if you're implementing your own kind of scripts as well. So just when heater on, don't read, and then just give it like a grace period to actually cool down. I'm only letting it cool down for 10 seconds, but it goes down to like 40 degrees-ish. It's probably better if it's actually in the little metal enclosure it comes with, because it will dissipate that heat a little bit faster, I think. You've probably noticed that I've got it on a circuit board. This is the actual circuit board I'm going to be putting into my bathroom, so it's got all of the fun stuff on it. It's literally a carbon copy of the kitchen one, but I've replaced the temperature sensor. That's kind of it. It's also just in a different layout. So now I need to install ESPHome, put a shell around it so that it doesn't, you know, get moisture on the bits that don't need moisture on them, and then see if it works in an actual real world scenario. So let's finish this one. Good news, everything is installed, and I've calibrated the sensors to like not detect me anywhere near here until I step into the bathroom where the lights turn on. That took slightly longer than I expected, but it worked. I don't have the light sensor programmed in yet, mostly because I don't know what the values of light in here are yet, but I do actually think it has a higher likelihood of working in here than it did in the kitchen. When it comes to the temperature sensor, I'm slightly worried. It's currently reading 25.3 degrees, and I'm slightly chilly, so it's definitely not that temperature, and I think it's my fault. I think because I didn't put any vent holes in the top of the actual box, all of the sensor heat is going up and into the temperature sensor. So I might keep an eye on that and adjust that in the future. But for now, I'm mostly interested in the actual humidity sensor. So I want to make sure that the heater turns on when it gets too humid. So I'm gonna go take a shower and come back to you with the results. and the rest of this clip is on Patreon. Okay, so I have some post-shower thoughts. It seems that the humidity level went to like 70% and then it dropped down. So I did set my limit to 70% and that's when it should turn the heater on. But I don't know if it turned the heater on or if I just stepped out of the shower when it reached 70%. I didn't give myself a way to actually see when the heater is on, so I might have to implement that in the next version. A couple other revisions is I also need to change the angle of the sensor currently, because it doesn't see me when I'm sitting on the toilet and you know, doing the old scrolly without moving very much. The light did turn off on me, so I just have to angle it down a little bit. And for the casing, I just need to implement those vent holes, because I'm pretty sure that's what's causing the temperature issue. I will have a look at it with the thermal camera before I do that, so I'll probably put that footage in here now. And yeah, I guess I'll implement the changes and I'll let you know how it goes. Okay, congratulations, you have made it to the conclusion part of this video. So I've done the changes that I said I was going to do. I've reprinted the enclosure, well, just the top of the enclosure with the vent holes, and then I've mounted it at an angle with some Velcro pads, and I've not had any issues of it not detecting me. In terms of the temperature sensor, I don't think it's actually done anything. It's still reading 24.2 degrees in here, and it's definitely not that warm. So I'm just gonna leave it for now and hope that it like fixes itself, but I'll keep an eye on it in the long run. I've added a readout to tell me when the actual heater on the thing is on. I also, in the configurations, added a slider that lets me change the humidity level at which the heater actually activates. And I've also implemented the light sensor. So now, when it's dark enough, the lights come on, but when there's a lot of light coming in through the window, it doesn't actually turn the lights on. And so I've got a slider for it, and I've got it set to 1.7 volts. So with my sensor, the higher the voltage, the darker it is in here. The way I ended up with 1.7 volts being the threshold is just by waiting for the sun to fill this room and then closing the curtain, and then that's what the readout was of the brightness in this room. So I figured if we're closing the curtains during the day, we probably want the light on. And lastly, I've added some sliders for LED brightness, one for during the day and one for during the night, which is from like 10 p.m. to 7 a.m. so that it doesn't blind us when we go to the bathroom in the middle of the night. And honestly, so far, I've been very happy with it. But you know, it doesn't really matter what I think. I kind of need to win some partner points, so let's go ask them. In a few words, what do you think about the bathroom lights?
I like them.
So with that, thank you very much for watching. Don't forget to like and subscribe. Support me on Patreon if you can. And I'll see you in the next episode. Goodbye. Why haven't the lights come on? Oh, it's bright enough in here for the lights to not come on. Well, at least that works. Bye.